Hi students, in this video we are going to study about gravity. Now we know every object in the universe attracts every other object with a gravitational force. Now if one object is Earth, then instead of gravitational force we use the term gravity. So gravity is the force of attraction between Earth and any object lying on or near the surface of the Earth. So it is a force of attraction between Earth and any object which lies near the surface of the Earth. So the equation for gravity is, for gravitational force it is F is equal to Gm1 m2 by r square. Now in this case one object is Earth, so we take, instead of m1 we take it as m. So the equation becomes F is equal to Gm small letter m divided by r square, where r is the distance from the surface, from the center of to the surface, or we can say it is the radius of the Earth. Now if we throw an object upwards, or if we project an object upwards, what happens? It reaches a particular height, its velocity becomes 0, then it comes down. Now why is it coming down? Because of the gravity, or because of the gravitational pull of the Earth. Now as the object is coming down, what happens? Its velocity will keep on increasing per second. So it means it is having an acceleration, and this acceleration is known by the name acceleration due to gravity. Now what is acceleration due to gravity? The acceleration produced in a freely falling body under the influence of gravitational pull of the Earth is called acceleration due to gravity, and it is denoted by the letter, small letter g. Now g is a vector quantity and its direction is directed towards the center of the Earth, and the equation relating small letter g and capital letter G is, small letter g is equal to g m by r square, where capital G is the universal gravitational constant, m is the mass and r is the radius of the Earth. Now from this equation it is clear that small letter g does not depend on shape, size of the object, but it depends only on what? Mass of the Earth. It depends on the altitude, that is the height from the center of the Earth, depth, rotation of the Earth, and its shape. So small to g is a variable term. It is not a constant. Depending upon the position of the object on or near to the surface of the earth, the value of g will vary. Depends on the rotation of the earth. It depends on the shape of the earth, etc. Now we are going to see what is the variation of g with altitude or height, which means what is the value or how much is the value of g when the object is kept above the surface of the earth on a particular height. For that, we consider earth to be a sphere, perfect sphere. Okay. Let O be the center of the earth and R the radius. Let M be the mass of the earth. So M is the mass of the earth, R radius of the earth, and earth in this case we are considering it to be a perfect sphere. Now imagine we are placing an object on the surface of the earth at point A. So acceleration due to gravity of the object having mass m on point A is given by G is equal to Gm divided by R square. This is equation 1. Now what I am going to do is, I am going to take this object and place it at a height h from the surface of the earth at point B. So now I have kept the object at point B, which is at a height h from the surface of the earth, or distance r plus h from the center of the earth. Therefore, acceleration due to gravity for the object at point B is I am going to denote it by G small letter h. Gh is equal to Gm divided by, now from the center of the earth to the distance of object is r plus h. So r plus h the whole square. This is equation 2. So at point A, acceleration due to gravity is Gm by r square. At a distance h from the surface of the earth, acceleration due to gravity is Gm divided by r plus h the whole square. Now I am going to compare these two equations. Sorry, I am going to divide these equations. So we get equation 2 by 1 gives Gh by G is equal to Gm divided by r plus h the whole square by Gm divided by r square. So we get Gh by G is equal to r square divided by r plus h the whole square. Put it in a box. This is equation 3. Now what I am going to do is I am going to solve this equation and make it simple. Okay. For that, first step what I am going to do is I am going to take this r outside. So we will get Gh by G is equal to r square divided by r square into 1 plus h by r square is equal to 1 by 1 plus h by r square, which can be written as what? 1 plus h by r the whole raised to minus 2, because 1 by x is x raised to minus 1. And next what step is, I am going to use the binomial expansion in this case. Now the binomial expansion for 1 plus x the whole raised to minus 2 is 1 minus 2x plus 3x square minus 4x cube, etc. So in our case x is h by r. So I am going to write gh by g is equal to 1 minus 2 into instead of x, it is h by r. So h by r plus 3 h by r the whole square plus the higher powers of h. Now the radius of the earth is approximately 6,400 kilometer. So we are going to do a comparison here. If it's a special condition, if h is very small compared to r, which means the object is placed very close to the surface of the earth when compared to the radius, then what happens? H by r will be less than 1, very much less than 1. Then if it is very much less than 1, for example 0.1, if you take the square, what happens? It becomes 0.01. Hence the higher powers of h by r can be neglected in this special condition if h is very much less than r, and we can write the relation between gh and g as gh by g is equal to 1 minus 2h by r, or gh, that is acceleration due to gravity at an altitude or height, is equal to g into 1 minus 2h divided by r. This is equation number 4. Now if you look into the equation, it is very much clear that the value of g at a particular height above the surface of the earth is less than the value of g on the surface of the earth. So we can conclude by writing from the above equation it is clear that acceleration due to gravity at an altitude is less than the value on surface of the earth. This is why if you compare the value of g with mountain and plain, mountain means from the center of the earth to the mountain peak, the distance is more when compared to that of the plain. So value of g will be always less in mountain than on plain. Okay. Now one thing which you have to remember regarding this equation is, this is equation 4, I am going to write equation 3 here. Equation 3 was gh by g is equal to r square divided by r plus h the whole square. It is regarding your problem solving. Now you can use this equation only if h is a value very small than r. Means for example, an object kept at a height of 34 km above the surface of the earth. So when compared to the radius 6,400 km, it is very small. So that time you can use this equation. Else we have to use this equation to solve the problem. So I'll say the step once more. What we did is we consider an object to be lying on the surface of the earth, and the equation for acceleration due to gravity is g is equal to gm by r square. Then we kept the object at a height h from the surface of the earth and formulated the equation as gh is equal to gm divided by r plus the whole square. Divided the equation, we found out the final equation, and we got two main equations, one which is used only if h is a value very small compared to the radius of the earth. Okay. Now let us solve one problem using this equation. At what height above the earth's surface the value of g is half the value on earth's surface? At what height above the surface of the earth the value of g, that is gh, is half its value on the surface of the earth. Given radius of the earth to be 6,400 kilometer. So, in our case r is equal to 6,400 kilometer, and they have given the hint the value of g at particular height is half the value on the surface of the earth. So, gh is equal to g by 2. Now, they have not given, we are also find out the height. So, we have to use a main equation, that is gh by g is equal to r square divided by r plus h the whole square. Or we can write gh is equal to g into r square divided by r plus h the. Now, instead of g h we can write g by 2. So, we get g by 2 is equal to g into r by r plus h the whole square, both are same. This can cancel. Or 1 by 2 is equal to r divided by r plus h the whole square. Taking the, in order to remove the square, what we do is we take the square root. So, we get 1 by root 2 is equal to r divided by r plus h, and rearranging we get r plus h is equal to root 2 into r, or h is equal to root 2 minus 1. We take this r to the side, becomes minus r, so root 2 minus 1 into r, which is root 2 minus 1 into 6,400 kilometer, and we get the answer as 2,649.6 kilometer. I hope this problem is clear to you. Thank you.